Being able to neutralize a reaction, whether acidic or basic, is a key part of being able to handle and manipulate chemical equations. So in this video, we are going to be talking about neutralization reactions and how if we have an acid, we can neutralize it to make that pH change in our favor. So to start, just going through these notes, we have water, and water is always going to have pure water. We're going to say it's neutral, so it will have a pH of 7, meaning it will have equal numbers of hydrogen ions and hydroxide ions. We talked about those in a previous video. If you need more, have more questions about that, I would refer you to watch that again. So water dissociates into hydroxide and hydrogen ions, one acid, in this case H+, and one base, right? We can also think about acids and bases. Acids are things that are able to donate hydrogens, and bases are things that are able to receive hydrogens or protons. All right, so our concentration of hydrogen ions and hydroxide are both 1.0 times 10 to the negative 7. And if we times our concentrations, again, this is kind of a review from our previous video where we talked about concentrations of hydrogen and hydroxide, we should get 1.0 times 10 to the negative 14 moles per liter. So that's just kind of, we're trying to always find that concentration of times 10 to the negative 14. But if an acid or base is added to water, it upsets the balance. Acidic solutions have an excess of hydrogen or H+ ions, and basic solutions have an excess of OH. So as we see in this scale, as we increase hydrogens, we go from 7 to 1, right? Or neutral to acidic. If we are increasing hydroxide, we're going from 7 to 14, which is going to be more basic. So one way to reduce toxicity of an acid or basic solution is by dilution. So that's like adding more water. The example I think of is concentrated orange juice or concentrate orange juice, which is a lot of pulp in it generally, versus just pulpless or unconcentrated orange juice, right? So it just has more water in it per liter than it does the substances that make up orange juice. Similarly, an acid, diluted acid, will have more water in it compared to a more concentrated acid. So to counteract the effects of an acid, you can add a base, and to counteract the effects of a base, you can add, an acid. And that leads us to our idea for this video, neutralization. So a neutralization reaction is when a base and acid cancel each other out to produce salt and water. Now that's going to be important for our problems and example problems that we'll see again. Right, so here we have HCl, that's our strong acid, plus sodium hydroxide, that's our strong base. We can see our hydrochloric acid is going to donate that hydrogen. Chloride is going to change place with hydroxide, and what we get is NaCl, which is a salt, and H2O, it's a liquid. All right, so that's going to be our big idea. Acids and bases neutralize each other, producing a salt and a water. So if we take a look at our neutralization reaction below, what patterns do you see? So I'll just take a few seconds, take a look at it, and see if you can find any trends. Let's see. So hopefully you might be able to see this. Each reaction results in the production of an ionic compound, also called a salt, plus water, right? So if we look, we can see these are all ionic compounds. So these are all different types of salts. And then we have water on the right side. All right, Next, some acids transfer more than one ion. So if we look at this guy, hydrosulfuric acid, H2SO4, that can actually donate 2 hydrogens, right? So this is a strong acid. It's going to easily dissociate with that first one. That turns into HSO4. This is a weak acid, and that's going to dissociate partially until eventually we get to SO4, and that's going to form with a metal, in this case, calcium. And then that -2 goes away. So each one could donate more than one H+ ion. If you see something that has H2 on it, it's most likely a strong acid. All right, so let's take a look at this example. Which of the acids and bases in this table could you mix to make potassium sulfate, K2SO4, right? A balanced chemical equation for the reaction. So a little deductive reasoning. We know our acid and base have to have potassium and sulfate. So looking at that, we only have 2 options. For our acids, we have to use hydrogen sulfate, so H2SO4, right? We need that SO4 in it. Plus, so we need to use a base here. That's going to be potassium hydroxide. And what will happen, leave some room for coefficients. We have the chemical equation occurred. So we know one of the products have to be potassium sulfate, K2SO4. And then our product, we could reason out what our product is based off of the reactants, but we also know this is a neutralization reaction. So we know always we're going to get water, right? A salt and a water, H2O. So then we have to balance it. If we do that quickly, we can see potassium has 2 here. So it's only 1 on the left, so we go ahead and put a 2 there. We then have 2 oxygens on this side. So we go ahead and put a 2 on the right-hand side, and that will balance us out. All right, so we just put 1 in for these other 2 guys. All right, and that is our example problem. So if you're asked to finish a chemical equation or make a chemical equation, make sure you have a salt and a water. All right, so lastly, stomach acid. Sometimes you can have excess amounts of stomach acid in your digestive tract, and that can cause irritation or burning, can cause upset stomach. And so sometimes there's an over-the-counter prescription you can get called milk of magnesia. And this is a common over-the-counter product that is a remedy for excess stomach acid. So it's a mixture containing magnesium hydroxide. And it looks like a milk and acts as a base. It's going to neutralize that strong acid. So stomach acid is a strong acid. It's made up of HCl, hydrochlorine. And this is going to produce a salt and water. Hydrochloric acid plus milk of magnesia turns into magnesium chloride plus water. So maybe you've had to use this recently, hopefully not, but if you've had any stomach issues, you might. All right, that was neutralization reactions. There's just some questions below, and I will talk to you guys later.